In the output we have the different departments, and on the right you can see the total salary of all the employees in each of these departments. Now here also you can give an alias name as total underscore salary. Let's run it again, and you can see the output here. Alright, now moving ahead, you can also use the order by clause along with the group by clause. Let's say you want to find the total number of employees in each city and group it in the order of employee ID. So to do this, I can use my select query. I'll write select count of, let's say, employee ID, and I want to know the city as well, from employees group by city, and next you can use the order by clause. I'll write order by count of employee ID, and I'll write DESC, which stands for descending. If I run this query, you can see here on the left you have the count of employees, and on the right you can see the city names. So in Chicago we had the highest number of employees working, that was 4. Then we had Seattle, Houston, Boston, Austin, and the remaining also had 2 employees. So in this case we have ordered our result based on the count of employee ID in descending order. So we have the highest number appearing at the top and then followed by the lowest. Okay, now let's explore another example. Suppose we want to find the number of employees that joined the company each year. We can use the year function on the date of joining column. Then we can count the employee IDs and group the result by each year. So let me show you how to do it. So I'll write select. I'm going to extract year from the date of join column. I'll give an alias as year. Next, I'll count the employee ID from my table name, that is employees, and I'm going to group it by year, date of join. I give a semicolon. Alright, so let's run this. Great. You see here in the result we have the year that we have extracted from the date of join column, and on the right you can see the total number of employees that joined the company each year. So we have in 2005 there was 1 employee. Similarly, we have in 2009 there were 2 employees. If I scroll down, you have information of other years as well. Now if you want, you can order this as well based on year or count. Okay. Now you can also use the group by to join 2 or more tables together. So to show you this operation, let me first create a sales table. So I'll write create table sales, and the sales table will have columns such as the product ID, which is going to be of integer type. Then we have the selling price of the product. Now this will be a float value. Then we have the quantity sold for each of the products. So I'll write quantity. Quantity will be of integer type. Next we have the state in which the item was sold, and state I'll put it as varchar and give the size as 20. Let's run this so that we'll create our sales table. Alright, so we have successfully created our sales table. Next, we need to insert a few values to our sales table. So I have already written the records in a notepad. Let me show you. Okay, so here you can see I have my sales text file. Let me just copy these information. I'll just paste it on the query editor. Okay, Now let me go ahead and run this insert command. Alright, so you can see here we have successfully inserted 9 rows of information. So let me just run it through what we have inserted. So the first column is the product ID column. Then we have the selling price at which this product was sold. Then we have the quantity that was sold and in which state it was sold. So we have California, Texas, Alaska. Then we have another product ID which is 123, and these are the states in which the products were sold. So let me just confirm with the select statement. I'll write select star from sales. If I run this, you can see we have successfully created our table. Okay. Now suppose you want to find the revenue for both the product IDs 121 and let's say 123, since we have just two product IDs here. So for that you can use the select query. So I'll write select product ID. Next, I want to calculate the revenue. So revenue is nothing but selling price multiplied by the quantity. So I'll use the sum function to find the total revenue, and inside the sum function I'll use my selling price column multiplied by my quantity column. I'll give this an alias name as revenue from my table name, that is sales. Finally, I'll group it by product ID. Let's run it. There you go. So here you can see we have the two product IDs 121 and 123, and here you can see the revenue that was generated from these two products. Alright. Now let's say we have to find the total profit that was made from both the products 121 and 123. So for that I'll create another table. Now this table will have the cost price of both the products. So let me create the table first. I'll write create table. Let's say the table name is C product, which stands for the cost price of the products. I'll give my first column as product ID. This will be an integer, and I'll have my second column as cost price. Cost price will have floating type values. Let's run this. So we have successfully created our product cost table. Now let me insert a few values into the C product table. So I'll write insert into C underscore product. I'll give my values for 121. Let's say the cost price was $270 for each, and next we have my product as 123, and let's say the cost price for product 123 was $250. Let's insert these two values. Okay. Next, we'll join our sales table and the product cost table. So this will give us the profit that was generated for each of the products. So I'll write select C dot product underscore ID, comma, I'll write sum S dot sell underscore price. Now here C and S are alias names. So if I subtract my cost price from the selling price, that will return the profit that was generated. I'll multiply this with S dot quantity, close the bracket. I'll give an alias name as profit from sales as S. So here S stands for the sales table. I'm going to use inner join C underscore product table, as the alias name should be C, where S dot product underscore ID is equal to C dot product underscore ID. We are using product underscore ID because this column is the common column to both the tables. And finally, I am going to group it by C dot product underscore ID. Alright. So let me tell you what I have done here. So I am selecting the product ID. Next, I am calculating the profit by subtracting the cost price from the selling price, and I have multiplied the quantity column. I am using an inner join to connect my sales and the product cost table, and I am joining on the column that is product ID, and I have grouped it by C dot product ID. Let's run this. There you go. So here you can see for product ID 121, we made a profit of $1,100, and for product ID 123, we made a profit of $840. So now that we have learnt group by in detail, let's learn about the having clause in SQL. The having clause in SQL operates on grouped records and returns rows where aggregate function results matched with given conditions only. So now having and where clause are kind of similar, but where clause can't be used with an aggregate function. So here you can see the syntax of having clause. You have the select statement followed by the column names from the table name, then we have the where conditions, next we have the group by, finally we have having, and at last we have order by column names. So you can see here we have a question at hand. We want to find the cities where there are more than 2 employees. So you can see the employee table that we had used in our group by clause as well. So if you were to find the cities where there are more than 2 employees, so this is how your SQL query should look like. So we have selected the employee ID and we are finding out the count using the count function. Next we have selected the city column. From employees, we have grouped it by city, and then we have used our having clause. So we have given our condition having count of employee ID should be greater than 2. So if you see the output, we have the different city names, and these were the cities where the count of employees was greater than 2. Alright, so let's go to our MySQL workbench and implement how having works. So suppose you want to find those departments where the average salary is greater than $75,000. You can use the having clause for this. So let me first run my table, which is employees. If I run this, you can see we had inserted 20 rows of information, and the last column we had was salary. So the question we have is, we want to find those departments where the average salary is greater than $75,000. So let me show you how to do it. So I'll write select department, comma, I'll use the aggregate function that is average salary. I'll give an alias name as avg underscore salary from employees. Next we'll use the group by clause, and I want to group it by each department, and then I'm going to write my having clause. So in having clause, I'll use my condition that is having average of salary greater than $75,000. Let's run it and see the output. There you go. So here you can see there were total 3 departments in the company, that is sales, finance and HR, where the average salary is greater than $75,000. Okay. Next, let's say you want to find the cities where the total salary is greater than $200,000. So this will again be a simple SQL query. So I'll write select city, comma, I want to find the total salary, so I'll use the sum function and I'll pass my column as salary, as I'll give a alias name as total from employees group by city, and then I am going to use my having clause. I'll pass in my condition as having sum of salary greater than $200,000. Alright, so let's run this query. There you go. So the different cities are Chicago, Seattle and Houston, where the total salary was greater than $200,000. Now suppose you want to find the departments that have more than 2 employees. So let's see how to do it. I'll write select department, comma. This time, since I want to find the number of employees, I'm going to use the count function. I'll write count star as employee underscore count or emp underscore count, which is my alias name, from employees. Next, I'll group it by department, having, I'll give my condition count star greater than 2. Let's run this. Okay, so you have departments such as sales, product, tech and IT, where there are more than 2 employees. Okay, now you can also use a where clause along with the having clause in an SQL statement. So suppose I want to find the cities that have more than 2 employees apart from Houston. So I can write my query as select city, comma, count star as emp count from employees, where I'll give my condition city not equal to Houston. I'll put it in double quotes since I don't want to see the information regarding Houston. I'll group it by city, having count of employees greater than 2. So if I run this query, you see we have information for Chicago and Seattle only, and we have excluded the information for Houston. Now you may also use aggregate functions in the having clause that does not appear in the select clause. So if I want to find the total number of employees for each department that have an average salary greater than $75,000, I can write it something like this. So select department, comma, count star as emp count from employees group by department, and in the having clause I'm going to provide the column name that is not present in the select expression. So I'll write having average salary greater than 75,000. This is another way to use the having clause. Let's run this. Alright, you can see we have department sales, finance and HR, and you can see the employee count where the average salary was greater than 75,000. Okay, so let me run you from the beginning what we did in our demo. So first we created a table called employee, then we inserted 20 records to this table. Next we explored a few SQL commands like distinct, then we used average, and finally we started with our group by clause, followed by looking at how group by can be used along with another table, and we joined two tables, that was sales and product cost table, to find out the profit. Then you learned how to use the having clause. So we explored several different questions and learned how to use having in SQL. In this session, we will learn about joins in SQL. Joins are really important when you have to deal with data that is present on multiple tables. I'll help you understand the basics of joins and make you learn the different types of joins with hands-on demonstrations on MySQL Workbench. So let's get started with what are joins in SQL. SQL join statement or command is often used to fetch data present in multiple tables. SQL joins are used to combine rows of data from two or more tables based on a common field or column between them. Now consider this example where we have two tables, an orders table and a customers table. Now the order table has information about the order ID, which is unique here. We have the order date, that is when the order was placed. Then we have the shipped date. This has information about the date on which the order was shipped. Then we have the product name, which basically is the names of different products. We have the status of delivery, whether the product was delivered or not, or whether it was cancelled. Then we have the quantity, which means the number of products that were ordered. And finally we have the price of each product. Similarly, we have another table called customers, and this customer table has information about the order ID, which is the foreign key here. Then we have the customer ID, which is the primary key for this table. We also have the phone number, customer name and address of the customers. Now suppose you want to find the phone numbers of customers who have ordered a laptop. Now to solve this problem, we need to join both the tables. The reason being, the phone numbers are present in the customers table, as you can see here, and laptop, which is the product name, is present in the orders table, which you can see it here. So using a join statement, you can find the phone numbers of customers who have ordered a laptop. Now let's see another problem where you need to find the customer names who have ordered a product in the last 30 days. In this case, we want the customer name present in the customers table and the last 30 days order information, which you can get from the order date column that is present in the orders table. Okay, now let's discuss the different types of joins one by one. So first we have an inner join. So the SQL inner join statement returns all the rows from multiple tables as long as the conditions are met. From the diagram above, you can see that there are two tables, A and B. A is the left table and B is the right table. The orange portion represents the output of an inner join, which means an inner join returns the common records from both the tables. Now you can see the syntax here. So we have the select command and then we give the list of columns from table A, which you can see here is the left table, followed by the inner join keyword and then the name of the table, that is B, on a common key column from both the tables A and B. Now let me take you to the MySQL Workbench and show you how inner join works in reality. So here I'll type MySQL. You can see I have got MySQL Workbench 8.0 version installed. I'll click on it. So it will take some time to open. Okay, I'll click on this local instance and here I'll give my password. Okay, so this is how an SQL editor on MySQL Workbench looks like. So first of all, let me go ahead and create a new database. So I'll write create database. This is going to be my command, followed by the name of the database, that is going to be SQL_joins. If I give a semicolon and hit Ctrl Enter, this will create a new database. You can see here one row affected. Now you can check whether the database was created or not using show databases command. If I run it, here you can see I have SQL joins database created. Now I'll use this database, so I'll write use SQL_joins. Okay. Now to understand inner join, consider that there is a college and in every college you have different teams for different sports such as cricket, football, basketball and others. So let's create two tables, cricket and football. So I'll write create table, and my table name is going to be cricket. Next, I'm going to create two columns in this table. The first column is going to be cricket ID. Then I'm going to give the data type as int and use the auto increment operator. I'm using auto increment because my cricket ID is going to be my primary key. Then I'm going to give the name of the students who are part of the cricket team, and for this I'll use varchar data type and give the length as 30. I'll give another comma and I'll assign my cricket ID as primary key. Within brackets I'll give cricket underscore ID. Cricket ID is nothing but a unique identifier for each of the players, like you have roll numbers in college. Okay, let me just run it. Alright, so we have successfully created our cricket table. Similarly, let me just copy this and I'll paste it here. I'll create another table called football. This will have the information of all the students who are part of the football team, and instead of cricket I am going to give this as football ID. Alright, and the name column will have the names of the students. I'll change my primary key to football ID. Alright, let me run this. Okay, so now we have also created our football table. The next step is to insert a few player names into both the tables. So I'll write my insert into command. First, let's load some data to our cricket table. So I'll write cricket and I'll give my name column followed by values, and here I'll give some names such as, let's say, Stuart. I'll give another comma. The next player I'll choose is, let's say, Michael. Similarly, I'll add a few more. Let's say we have Johnson. The fourth player I'll take is, let's say, Hayden. And finally we have, let's say, Fleming. Okay, now I'll give a semicolon and run this. Okay, so let me just check if all the values were inserted properly. For this I'll use select star from table, that is cricket. If I run it, you can see I have created a table and have successfully inserted 5 rows of information. Now similarly, let's insert a few student names for our football table. So I'll change this to football, and obviously there would be students who will be part of both cricket and football team. So I'll keep a few repeated names. Let's say Stuart, Johnson, and let's say Hayden are part of both cricket and football team. Then we have, let's say, Langer, and let's say we have another player in the football team, that is Aston. I'll just run it. Okay, you can see there are no errors. So we have successfully inserted values to our football team as well. Let me just recheck it. I'll write select star from football. Alright, so we have 5 players in the football team as well. Okay, now the question is, suppose you want to find the students that are part of both the cricket and football team. In this case you can use an inner join. So let me show you how to do it. So I'll write select star from cricket, as I'm using an alias name as C, which stands for cricket. Then I'm going to write inner join. My next table is going to be football as F, which is an alias name for the football table. Then I'm going to use the on command or operator, and then I'll give the common key, that is name here. So c dot name is equal to f dot name. So based on this name column from both the table, my inner join operation will be performed. So let's just run it. There you go. So Stuart, Johnson and Hayden are the only 3 students who are part of both the teams. Alright. Now you can also individually select each of the columns from both the tables. So let's say I write select c dot cricket underscore id, comma c dot name, comma f dot football underscore id, comma f dot name. From, I'll write cricket as C, inner join football as F, on C dot name is equal to F dot name. Now if I run this, you see we get the same output here as well. Alright. Now let's explore another example to learn more about inner joins. So we have a database called classic models. Let me first use classic models. I'll run this. Okay. Now let me just show the different tables that are part of classic tables. Alright. So here you can see there are tables like customers, there's employees, office, there's office details, orders, payments, products and product lines as well. Alright. So let me use my select statement to show what are the columns present in the products table. Okay. So this product table has information about different product names. You have the product code. Now this product code is unique here. We also have the product vendor, a little description about the product, then we have the quantity in stock, buying price and MSRP. Let's see what we have in product lines. If I run it, you see here we have the product line, which is the primary key for this table. Then we have the textual description for each of the products. This is basically some sort of an advertisement. Alright. Now suppose you want to find the product code, the product name and the text description for each of the products. You can join the products and product lines table. So let me show you how to do it. I'll write my select statement and choose my columns as product code. Then we have product name, and let's say I want the text description. So I'll write this column name. Okay. Then I'll use from my first table, that is products, inner join product lines. I can use using the common key column, that is product line. Close the bracket, I'll give a semicolon, and if I run it, there you go. So you can see the different product codes, then we have the different product names and the textual description for each of the products. So this we did by joining the products table and the product lines table. Alright. Now suppose you want to find the revenue generated from each product order and the status of the product. To do this task, we need to join 3 tables, that is orders, order details and products. So first let me show you what are the columns we have in these 3 tables. We have obviously seen for the products table. Now let me show you for orders and order details table. So I'll write select star from orders. If I run it, you can see it has information about the order number, the date on which the order was placed, We also have the shipment date. We also have the status column, which has information regarding whether the order was shipped or cancelled. Then we have some comments column. We also have the customer number who ordered this particular product. Similarly, let's check what we have under order details. So I'll write select star from order details. If I run it, you can see it has the order number, the product code, quantity of each product. We have the price of each product. Then we have the order line number. Okay. So using the product orders and order details, let's perform an inner join. So I'll write select O dot order number, comma, O dot status, comma, I need the product name which I'll take from the products table. So I'll write P dot product name. Now here O, P are all alias name for the tables, orders, products, and I'll use OD for order details, comma, since we want to find the revenue, we actually need to find the product of quantity ordered into price of each product. So I'll use a sum function, and inside the sum function I'll give quantity ordered multiplied by the price of each item. I'll use an alias as revenue. Then I'll use my from clause, from orders as O, inner join order details as I'll use an alias name as OD, on I'll write O dot order number is equal to OD dot order number. I'll use another inner join, and this time we'll join the products table. So I'll write inner join products as P on P dot product code is equal to OD dot product code. And finally I'll use the group by clause and group it by order number. Alright, let me run this. Okay, there's some mistake here. We need to debug this. It says you have an error in your SQL syntax. Check the manual. Alright. Okay, I think the name of the tables is actually orders and not order. Alright, now let's run it. Okay, there's still some error. It says classic models dot product doesn't exist. So again, the product name is, the table name is products and not product. So let's run it again. Alright, there you go. So we have the order number, the status, the product name, and the revenue. This we got it using inner join from 3 different tables. Now talking about left joins, the SQL left join statement returns all the rows from the left table and the matching rows from the right table. So if you see this diagram, you can see we have all the rows from the left table, that is A, and only the matching rows from the right table, that is B. So you can see this overlapped region, and the syntax for SQL left join is something like this. So you have the select statement, and then you give the list of columns from table A, which is your left table. Then you use the left join keyword followed by the next table, that is table B, on the common key column. So you write A dot key is equal to B dot key. Okay, now in our classic models database we have 2 tables, customers and orders. So if you want to find the customer name and their order ID, you can use these 2 tables. So first let me show you the columns that are present in customers and orders. I think orders we have already seen. Let me first show you what's there in the customers table. Okay, so you can see we have the customer number, the name of the customer, then we have the contact last name, the contact first name, we have the phone number, then there's an address column. There are two address columns actually. We have the city name, the state, and we have other information as well. And similarly we have our orders table. So I'll write select start from orders. So I'll write select star from orders. If I run this, you can see these are the information available in the orders table. Okay, so let's perform a left join where we want to find the customer name and their order IDs. So I'll write select c dot customer name, or let's say first we'll choose the customer number, comma, then I want the customer name, so I'll write c dot customer name. Then we have the order number column which is present in the orders table, and let's say I also want to see the status. Then I'll give my left table, that is customers as C, left join, orders as O, on C dot customer number equal to O dot customer number. Let's run it. Okay, again there is some problem. Alright, so the table name is customers. Let's run it. So there's another mistake here. This is customer number, so B is missing. Cool. Let me run it. Alright, so here you can see we have the information regarding the customer number, then the respective customer names, we have the order number and the status of the shipment. So if I scroll down, you'll notice one thing, there are a few rows you can see which have null values. This means for customer number 125 and for this particular customer name there were no orders. And similarly if I scroll down, you will find a few more null values. You can see here there are two null values here. For customer number 168 and 169 there were no orders available. Alright, now to check those customers who haven't placed any orders, you can use the null operator. So what I'll do is here I'll just continue with this. I'll use a where clause and write where order number is null. Now let me run this. Okay, so here you can see there are 24 customers from the table that don't have any orders in their names. Okay, now talking about right joins. So SQL right join statement returns all the rows from the right table and only matching rows from the left table. So here you can see we have our left table as A and the right table as B. So the right join will return all the rows from the right table and only the matching rows from the left table. Now talking about the syntax. So here you can see we have the select statement. Followed by the select statement, you will have the list of columns that you want to choose. From table A, right join table B on the common key column from both the tables. Alright. Now to show how right join works, I'll be using two tables, that is customers and employees. So let's see the rows of data that are present in the customer table first. So I'll write select star from customers. Let's run it. So here you have the customer number, the customer name, then we have the phone number, the address of the customers. You also have the country to which the customer belongs to, the postal code, and the credit limit as well. Similarly, let's see for the employees table. Here I'll change customers to employees. Let's run it. Okay, so we have the employee number, the last name, the first name, we have the extension, the email ID, the job title, and also reports to here means the manager. Okay, so based on these two tables, we'll find the customer name, the phone number of the customer, and the email address of the employee. and join both the tables, that is customers and employees. So let me show you the command. So I'll write select c dot customer name, comma, then we have c dot phone. I'll give a space here. Next, I want the employee number from the employee table, so I'll write e dot employee number, comma, e dot email from customers as C, right join employees as E on e dot, my common key column is employee number here, so I'll write e dot employee number is equal to C dot, we have sales representatives employee number, and I'm also going to order it by the employee number column. Okay, so you can see I have my customer name selected from the customers table, the phone number of the customer, then we have the employee number and the email address. So let me run it. Okay, there's some problem. Alright, so the table name is customers actually. Let's run it once again. There you go. So you can see here we have all the values selected from our right table, which is the employees table. You can see right join employees, which means your employees table is to the right, and then we have the customer name and phone numbers of the customers from the customer table, which is actually your left table. So you have a few employee numbers such as 1002, there's 1056, which don't have any customer name or phone numbers. Okay, so there's another popular join which is very widely used in SQL, known as self joins. So self joins are used to join a table to itself. So in our database we have a table called employees. Let me show you the table first. Alright, so here you can see we have the employee number, the last name, the first name of the employee, we have the email ID, and here if you see we have a column called reports to. Now this you can think of as the manager column. So the way to read is, for example, for employee number 1056, the manager is 1002. So if you check for 1002, we have Dane Murphy. Then if I scroll down, let's say for employee number 1102, for employee number 1102, the manager is 1056. So here you can see who is at 1056. You have Mary Patterson. Similarly, if I scroll down, let's say for employee number 1188, we have the manager as 1143. Now if I check the table at 1143, we have Anthony Bow. So the employee Julie Firelli reports to Anthony Bow. Alright, now suppose you want to know who is the reporting manager for each employee. So for that you can use a self join. So let me show you how to join this employees table. I'll write select, and then I'm going to use a function called concat. Within brackets I'll start with my alias name, that is m dot, then I'll write last name. I'm going to concat last name followed by a comma, then I'll have my first name. I'll close this bracket, and then I'm going to give my alias name, let's say manager, comma. Next I'm going to concat the same last name and first name, and this time I'm going to use a separate alias, let's say E, which stands for employee. So I'll write E dot last name, comma, and within single quotes I'll give my comma, and then I'll write E dot first name. I'll close this bracket. I'll give an alias as, let's say, employee. From, I'll write employees as E, inner join employees as M on M dot. I'll use my common key column as employee number, so I'll write M dot employee number is equal to E dot, here I'm going to use the reports to column, and then I'll order it by, let's say, manager. Okay, now let's run this. There you go. So you have your two columns as manager and employee. So for employee Louis Bonder, the manager is Gerard Bonder. Similarly, if I scroll down, you have there are multiple employees reporting to this particular manager. Similarly, we have our manager as Anthony Bow, and we have different employees who are reporting to this particular manager, and so on. Alright, now moving ahead. Now let's see what a full join is. So SQL full outer join statement returns all the rows when there is a match in either left or right table. Now you must remember that MySQL Workbench does not support full outer join by default, but there's a way to do it. So by default, this is how the syntax of full outer join looks like. Now this statement will work on other SQL databases like Microsoft SQL Server, but it won't work on MySQL Workbench. I'll show you the right way of using full outer join on MySQL Workbench. So to show full outer join, I'm going to first use a left join, and then we'll also use a right join, and finally we'll use a union operator. So the union operator is used to combine the result set of two or more select statements. So first of all, let me write C dot customer name. So for this example, I'm using the customer table and the order table, comma O dot order number. So I just want to know the customer name and the order number related to the customer. From, I have customers as C, left join, I'll write orders as O on C dot customer number is equal to O dot customer number. Let me just copy this, and after this I am going to use my union operator. So union operator is used to merge results from two or more tables. So basically this performs a vertical join. And next I am going to use my right join operation. So here instead of left join, I'll write right. Rest all looks fine. Let me just run it. There you go. So we have successfully run our full outer join operation. You can see we have the different customer names and the order that each customer had placed. Alright, so that brings us to the end of our demo session. So let me just run through whatever we did in this session. So first we created a database called SQL joins. Then we created two tables like cricket and football. Then we had inserted a few rows to each of these tables. Then we used this table to learn about inner join. Next, we used a database called classic models. It had multiple tables, so we explored all of these tables like products, there was product lines, orders, customers and employees, and learned how to use inner join, left join, self join, right join, as well as full outer join. In this video, we will learn what is a subquery and look at the different types of subqueries. Then we'll learn subqueries with select statement followed by subqueries with insert statement. Moving further, we will learn subqueries with the update statement, and finally we look at subqueries with delete statement. All this we will be doing on our MySQL workbench. So before I begin, make sure to subscribe to the Simply Learn channel and hit the bell icon to never miss an update. So let's start with what is a subquery. So a subquery is a select query that is enclosed inside another query. So if I show you, this is how the basic structure of a subquery looks like. So here, whatever is present inside the brackets is called as the inner query, and whatever is present outside is called the outer query. So first, the inner query gets executed and the result is returned to the outer query, and then the outer query operation is performed. Alright, now let's see an example. So we have a question at hand, which is to write a SQL query to display department with maximum salary from employees table. So this is how our employees table looks like. It has the employee ID, the employee name, age, gender, we have the date of join, department, city and salary. Now to solve this query, my subquery would look like this. So I'll first select the department from my table, that is employees, where I'll use the condition salary equal to, and then I'll pass in my inner query, which is select max of salary from employees. So what this does is it will first return the maximum salary of the employees in the table. Then our outer query will get executed based on the salary returned from the inner query. So here the output is department sales has the maximum salary. So one of the employees from the sales department earns the highest or the maximum salary. If you see in our table, the employee is Joseph, who earns $115,000. Alright, and Joseph is from the sales department. Now let's see how this query works. So here we have another question, which is to find the name of the employee with maximum salary in the employees table. So this is our previous employees table that we saw, and to find the employee who has the maximum salary, my subquery would look something like this. So I'm selecting the employee name from my table, that is employees, where I'm using the condition salary equal to, and then I'm passing in my subquery or the inner query. So first I'm selecting the maximum salary. This will return a particular value, that is the highest salary from the table. And if you see our table, the highest salary is $115,000. So our query becomes select employee name from employees where salary equal to $115,000. So the employee name is Joseph here, and that's the output. Now if you want to break it down, here you can see first the inner query gets executed. So our SQL query will first execute the inner query that is present inside brackets, select maximum salary from employees. The result is $115,000, and then based on the returned result, our outer query gets executed. So the query becomes select employee name from employees where salary equal to $115,000, and that employee is Joseph. Alright, now we'll learn the different types of subqueries. So you can write subqueries using select statement, update statement, delete and insert statement. We'll explore each of this with the help of example on my MySQL workbench. So let's learn subqueries with the select statement. So subqueries are majorly used with the select statement, and this is how the syntax looks like. You select the column name from the table name, then you have the where condition followed by the columns that you want to pass, the operator, and inside that you have the subquery. So here is an example that we will perform on our MySQL workbench. So in this example, we want to select all the employees who have a salary less than average salary for all the employees. This is the output. So let's do this on my MySQL workbench. Alright, so let me log into my local instance. I'll give my password. Okay, so you can see I'm on my MySQL workbench. So let's start by writing our subquery using the select statement. Okay, so for this demo session, we'll be using a database that is subqueries. You can see it here. I have a database called subqueries. So I'll use this subqueries database and we'll create a few tables as well. Okay, If I run it, now we are inside the subqueries database. So let me just show you the tables that are present inside this database. I'll write show tables. If I run it, okay, there are two tables, employees and employees underscore B. We'll use this table throughout our demo session. Alright, now for our select subquery, we want to fetch the employee name, the department and the salary whose salary is less than the average salary. So we will be using the employees table. So let me first show you the records and the columns we have in the employees table. So I'll write select star from employees and run it. Okay, you can see here we have 20 rows of information. We have the employee name, the employee ID, age, gender, date of join, department, city and salary. So this is the same table that we saw in our slides. Okay, now for our subquery, I'll write select. I want to choose the employee name, the department and the salary. There should be a comma here instead of a period. Next, I'll give my table name, that is employees, where my salary is less than, and after this I'll start my inner query or the subquery. I'll write select average salary. So I'm using the AVG function to find the average salary of all the employees from my table, that is employees. If I give a semicolon and run this, you'll see the output. So we have total 12 employees in the table whose salary is less than the average salary. Now if you want, you can check the average salary. So the average salary is $75,350. Now the employees who have a salary less than the average salary, so these are the people. Alright, now moving back to our slides. Okay, now let's see how you can use subqueries with the insert statement. Now the insert statement uses the data written from the subquery to insert into another table. So this is how the syntax looks like. So you write insert into table name followed by select individual columns or star from the table, use the where clause, and then you give the operator followed by the inner query or the subquery. So here we will explore a table called products table. We are going to fetch few records from the products table based on a condition, that is the selling price of the product should be greater than $100. So only those records will fetch and put it in our orders table. Alright, so we are going to write this query on my MySQL workbench. So let's do it. I'll give my comment as update subquery. Alright, so first of all let's create a table, that is products. So I'll write create table products. Then we'll give our column names. The first column would be the product ID of type integer. Then we have the column as item or the product, which is of type varchar 30. Next we have the selling price of that product. The selling price will be of type float. And finally we have another column which is called the product type. And again product type is of the data type varchar. I'll give the size as 30, close the bracket and give a semicolon. Now let's just run it. Okay, so we have successfully created our products table. Now let's insert a few records to our products table. So I'll write insert into products followed by values. I'll give 4 records. The first product ID is 101. The product is, let's say, jewelry. Then the selling price is, let's say, $800, and the product type is, it's a luxury product. Next let's insert one more product detail. The product ID is 102. the product is, let's say, t-shirt, the price is, let's say, $100, and the product type is non-luxury. Next, I'll just copy this to reduce our task. We'll edit this. The third product's ID is 103. The product is laptop, and let's say the price is $1,300 and it's a luxury product. I'll paste again, and finally I'll enter my fourth product, which is, let's say, table, and the price is $400 and it's a non-luxury product. I'll give a semicolon and we'll insert these 4 records to our products table. You can see we have inserted 4 records. Let's just print it now. So I'll write select star from products. If I run it, you can see we have our 4 products ready. Now we need to create another table where we are going to put some records from our products table. So that new table is going to be the orders table. So I'll write create table orders. Now it will have 3 columns. The order ID will be of type integer. Then we have product underscore sold. This will be of type varying character of size 30. And finally we have the selling price column. This will be of type float. Let's create our orders table. The table name should be orders, and there is some mistake here. Okay, you should close the brackets. Okay, let me run it. So we have our orders table ready. Now let's write our insert subquery. So I am going to insert into my table, that is orders, and I'll select the product ID, comma, the item and the selling price or the sell price from my table, that is products, where I'll write product ID in. I'll write my inner query select prod ID or the product ID from products. Next, I'll give a where clause where the selling price is greater than $1,000. So let me tell you what I am going to do here. I am going to insert into my orders table the product ID, the item name and the selling price from my products table, where the product ID has this condition. So let me first run this condition for you, which is select prod ID from products where the selling price is greater than 1000. If I run this, okay, there is some issue here. The column name is actually prod ID. Now let's run it again so that we can see the product IDs of the products which have a selling price greater than 1000. So it is 101 and 103. Now let's run the entire query. There is another mistake here. Let's debug the mistake. Now this should be product ID instead of product underscore in. Let's insert again. Alright, so we have successfully inserted 2 records to our table, that is orders. Now let's see the orders table. I'll write select star from orders. If I run it, there you go. So there were 2 products from our product table that were jewelry and laptop, which have a selling price greater than $1,000. So the selling price for jewelry was $1,800 and for laptop it was $1,300. So this is how you can use a subquery using the insert statement. Alright, now going back to our slides again. Alright, now let's see how you can use subqueries with the update statement. Now the subqueries can be used in conjunction with the update statement. So either single or multiple columns in a table can be updated when using a subquery with the update statement. So this is how the basic syntax of an update subquery looks like. So you write update table followed by the table name, you set the column name, you give the where operator, and then you write your inner subquery. So we are going to see an example where we will use this employees table, and using this employees table we will update the records of the salaries of the employees by multiplying it with a factor of 0.35 only for those employees which have age greater than 27. So we are going to use a new table called employees underscore b for this as well. So let's see how to do it. So I'll give my comment as update subquery. Before we see the subquery, let's see what we have in the table employees underscore b. This is basically a replica of the employees table. There you go. It has the same records that our employees table has. We are going to use both the employees table and the employees underscore b table to update our records. So I'll write update employees set salary equal to, let me bring this to the next line. I'll write set salary equal to salary multiplied by 0.35, where age in, then I'll write select age from my other table, that is employees underscore b, where age is greater than or equal to, let's say 27. Alright, so let me run through this query and tell you what we are going to do. So I'm going to update the records of the employees table specifically for the salary column. So I'm checking if the age is greater than 27, then we'll multiply the salaries of the employees with a factor of 0.35 in the employees table. Let me just run this, then we'll see our output. Okay, so it says 18 rows affected, which means there are total 18 employees in the table out of the 20 employees whose age is greater than 27. Now if you see, I'll write select star from employees. You can see the difference in the salaries. If I scroll to the right, you can see these are the updated salaries. Okay. Now if you check for employees who have an age less than or equal to 27, for example Marcus, whose age is 25, his salary is the same. We haven't updated his salary. Then if you see, if we have, okay, there is one more employee, Maya. We haven't updated the salary of Maya because the age is less than 27. Alright. Now let's go back to our slides again. As you can see, we got the same output on our MySQL workbench. Now let's explore how you can write subqueries with the delete statement. Now subqueries can again be used in conjunction with the delete statement. So this is how the basic syntax of a delete query using subquery would look like. You write delete from the table name, where clause, the operator value, followed by the inner query in within brackets. So here we are going to use the employees table, and what we are going to do is we'll delete the employees whose age is greater than or equal to 27. So let's see how you can do it. Alright, so I'll give my comment as delete subquery. So we'll follow the syntax that we saw. I'll write delete from my table name, that is employees. I'll write where age in, and then I'll start my inner query or the subquery. I'll write select age from employees underscore b, where age is, let's say, greater than or equal to 32, or let's say the age is less than equal to 32. Close the bracket and I'll give my semicolon. Let me first run the inner query for you so that you get an idea of the employees who are less than 32 years of age. So there are 9 employees in the table who have an age less than equal to 32. So we are going to delete the records. If I run this, okay, it says 9 records deleted. Now let's print or display what we have in the employees table. If I run this, there you go. So if you see the age table, we have total 11 employees now, and all their ages are greater than 32 because we have deleted all those employees who had an age less than equal to 32. Okay, so let me show you from the beginning what we did. So first we used our subqueries database, then we used our employees table. So we started by looking at how you can use the subquery with a select statement. This should be insert instead of update. So we learned how to write an insert subquery. We use two tables, products and our orders table. Moving ahead, we saw how to write subqueries using the update command. So we updated the salaries of the employee by a factor of 0.35 for those who had an age greater than equal to 27. And finally, we saw how to use the subquery using the delete statement. So we deleted all those records for the employees whose age was less than equal to 32.
So let's start with what is normalization. Normalization in DBMS is a method used to organize data within database to reduce repetition. By breaking down large data sets into smaller, more manageable tables and ensuring these tables are properly related, normalization helps prevent issues like data redundancy. Data redundancy means the unnecessary repetition or duplication of data within a database. For example, when a same piece of data is stored in multiple places, it can lead to inconsistencies and take up more storage space than needed. For example, data redundancy before normalization. You can see the table mentioned above where we have order ID, customer name, customer address, product and quantity. You might see some of the data which is being repeated again and again. In the above table, the customer address for John Doe is repeated 3 times. Let's suppose if John Doe moves to a new address, every occurrence of his address in the table must be updated. If any instance is missed during the update, it leads to inconsistencies and errors can occur in the database. The solution is reducing the redundancy through normalization. Let's check it out how. So you can see this is the normalized table we have created. First is the normalized customer table and then we have the order table. So what are the benefits of normalization? The address for John Doe is stored only once in the customer table. If John Doe's address changes, it needs to be updated in one place, ensuring consistency through the database. This reduces the risk of errors and maintains data integrity. The process involves multiple steps that transform data into a tabular format, removing duplicates and establishing clear connections between different tables, making the database more efficient and reducing problems like errors during data insertion, updates, or deletion. Let's now discuss the types of DBMS normal forms. Normalization rules are categorized into different normal forms. The first one is 1NF. For a table to be in first normal form, it must satisfy the 4 rules. Single-valued atomic attributes. Each column should contain only one value per row. This means that there should be no repeating groups or arrays within a single column. Same domain values. All values stored in a specific column should be of the same data type or domain. For example, if a column is meant to store dates, all values in that column should be dates. Then we have unique column names. Each column in the table should have a unique name. This ensures clarity and avoids confusion when referring to a specific column. Then we have order of data, which doesn't matter. The order in which rows are stored in the table should not affect the data or its integrity. Let's check the example of the first normal form. Consider the following unnormalized table: customer ID, customer name, and the phone numbers. As you can see, the phone numbers are repeated twice. The problems with the original table is the non-atomic values. The phone numbers column contain multiple phone numbers separated by commas, which violates the atomicity rule of 1NF. Converting to first normal form, to bring this table into 1NF, we must ensure that each column contains only atomic value. This involves splitting the rows where there are multiple phone numbers. As you can see, we have splitted the data. Each row now has a single phone number, ensuring that the phone number column contains atomic value. Same domain names, all the values in the phone number column are consistent in format and type. All are phone numbers. Then we can see that the unique column names, the columns customer ID, customer name, phone number, which has unique name satisfying the requirement. Order of data. The order in which the rows appear does not matter, as the data's meaning and integrity are preserved. By applying these rules, the table now conforms to the first normal form, eliminating any redundancy related to the phone numbers and ensuring data is stored in a more organized and efficient manner. Let's go through each of these database normal forms step by step with simple examples to help you grasp the concepts more easily. Let's talk about the second normal form. For a table to be in second normal form, it must satisfy the following condition. Number 1, it must be in 1NF. Number 2, no partial dependency. Every non-key attribute should be fully dependent on the entire primary key, not just part of it. This rule applies primarily to tables with composite primary keys. Example of second normal form is, consider the following table that is in 1NF. The order ID, product name, quantity, and the supplier name. The problems with this table is that the partial dependency. The product name and the supplier name depend only on product ID, not the entire primary key, which is order ID and product ID. This violates 2NF. Converting to second normal form, to bring the table into 2NF, we separate the data into two tables to remove partial dependencies. Order table and the product table. No partial dependency in the order table. Quantity is fully dependent on both order ID and product ID. In the product table, product name and supplier name are dependent only on the product ID. This ensures that each non-key attribute is fully dependent on the primary key, bringing the tables into 2NF. Let's now talk about the third normal form, 3NF. For a table to be in third normal form, it must satisfy the following condition. Number 1, it must be in 2NF. Number 2, there should be no transitive dependency where non-key attributes depend on other non-key attributes rather than the primary key. Let's check out the example of a third normal form. Consider the following table that is in 2NF. The problems with the 2NF table is that the transitive dependency. The instructor name is dependent on the course name, which is not directly on student ID or course ID, and this violates 3NF. So how do we convert this into 3NF? To achieve 3NF, we split the table to remove the transitive dependency. Student course table and course table. No transitive dependency. Now, the student course table, there are no non-key attributes depending on other non-key attributes. The course table stores the course and instructor information separately. This structure eliminates transitive dependency, ensuring the tables conform to 3NF. Let's now talk about the Boyce Codd normal form, which is BCNF. BCNF is an extension of the third normal form, 3NF. A table is in BCNF if it is in 3NF, and for every functional dependency, A implies to B, A should be a superkey. Let's check out the example of a Boyce Codd normal form BCNF. So you can see this table here consisting of employee ID, department, and the manager. The problem with this table is that the BCNF violation. In this table, department determines manager, but department is not a superkey, since employee ID is the primary key. This violates BCNF. So how do we convert this to BCNF? To achieve BCNF, we split the table to ensure that every determinant is a superkey. As you can see, the employee table and the department table. The superkey requirement in the employee table, employee ID is the primary key, and in the department table, department is now the primary key. The decomposition ensures that every functional dependency is satisfied by a superkey, meeting the requirements of BCNF. Let's now talk about the fourth normal form, which is 4NF. A table is said to be in 4NF if it is in BCNF and has no multi-value dependencies. So let's consider an example of a fourth normal form. Consider a table where an employee can have multiple skills and work on multiple projects. As you can see the employee ID, skill, and the project. The problem with this table is that it is multi-value dependency. An employee skill is independent of the project, but both are stored in the same table. This leads to multi-value dependency, violating 4NF. So, in order to achieve 4NF, we separate the skills and the projects into different tables: the employee skill table and the employee projects table. And now you can see that no multi-value dependency. By separating the skills and the projects, we eliminate multi-value dependencies, ensuring the table conform to 4NF. Let's now talk about the fifth normal form, the employee skill table and the employee projects table. So as you can see that no multi-value dependency is there. By separating the skills and the projects, we eliminate multi-value dependencies, ensuring the tables conform to 4NF. Now let's talk about the fifth normal form, which is 5NF. A table is said to be in fifth normal form if it is in 4NF and cannot be decomposed into any smaller tables, losing information, also known as joint dependency. Let's consider an example of a fifth normal form. This is a table here that records the relationship between suppliers, parts, and a project. The problem with this table is that the joint dependency. The table has a complex relationship between suppliers, parts, and projects that can be decomposed further. So how do we convert this into fifth normal form? In order to achieve 5NF, we break the table into smaller related tables: the suppliers part table and the suppliers project table, also parts project table. Eliminating joint dependency, by decomposing the table into 3 smaller tables, we remove the complex relationship and eliminate the joint dependency, ensuring the tables conform to 5NF.
So currently I am on my MySQL workbench. Let me connect to the local instance. So I'll give my password. I'll click on OK. Alright. So this is my MySQL workbench query editor. So first we are going to learn subqueries. Let me give a comment and write subqueries. Alright. So first of all, let's understand what a subquery is. So a subquery is a query within another SQL query that is embedded within the where clause, from clause, or having clause. So we'll explore a few scenarios where we can use subqueries. So for that, I'll be using my database, that is SQL_intro. So I'll write my command use SQL_intro. Now this database has a lot of tables. I'll be using the employees table that is present inside SQL_intro. Let me just expand this, and you can see here we have an employees table. So let me first show you the contents within this table. I'll write select star from employees. Let me execute it. Okay, you can see here we have the employee ID, employee name, age, gender, there's date of join, department, city, and salary, and we have information for 20 employees. If I scroll down, you can see there are 20 employees present in our table. So let's say you want to find the employees whose salary is greater than the average salary. In such a scenario, you can use a subquery. So let me show you how to write a subquery. I'll write the select statement. In the select statement, I'll pass my column names that I want to display. So the column names I want are the employee name. Then I want the department of the employee and the salary of the employee from my table name, that is employees. Next, I'll use a where condition where my salary should be greater than the average salary of all the employees. So I'll write salary greater than. After this, I'm going to write my subquery. So I'll give select average of salary from my table name, that is employees, and I'll close the bracket and give a semicolon. So what it does is, first it is going to find the average salary of all the employees that are present in our table. Once we get the average salary number, we'll use this where condition where salary is greater than the average salary number. So the inside subquery, let me run it first. If I run this, this gives you the average salary of all the employees, which is $75,350. Now I want to display all the employees who have salary greater than $75,350. So let's run our subquery. There you go. So there are 8 employees in our table who have a salary greater than the average salary of all the employees. Alright. Next, let's see another example. Suppose this time you want to find the employees whose salary is greater than John's salary. So we have one employee whose name is John. Let me run the table once again. Okay, if I scroll down, you see we have an employee as John. You see this? Our employee ID 116 is John and his salary is $67,000. I want to display all the employees whose salary is greater than John's salary. So basically all the employees who are earning more than $65,000, I want to print them. So let's see how to do it. I'll write select. I want the employee name, comma, the gender of the employee. I also want the department and salary. From my table name, that is employees, I'll write where salary is greater than. I'll start my opening bracket. Inside the bracket, I'm going to give my inner query, that is select salary from employees where the employee name is John. So within single quotations, I'll give John as my employee. I'll end with a semicolon. So let me first run my inner query. So this will give us the salary that John has, which is $67,000. Now I want the employees who are earning more than $67,000. So let's run our subquery. Okay, so you can see 12 rows returned, which means there are 12 employees in our table who are earning more than $67,000. You see here, all these employees have a salary greater than $67,000. Okay. Now, you can also use subqueries with two different tables. So suppose you want to display some information that are present in two different tables, you can use subqueries to do that. So for this example, we'll use a database that is called classic models. You can see the first database. So let me use this database called classic models. I'll write use classic models. Now this database was actually downloaded from the internet. There's a very nice website. I'll just show you the website name. So this is the website, that is mysqltutorial.org. You can see here they have very nice articles, blogs from where you can learn MySQL in detail. So we have downloaded the database, that is classic models, from this website. You see here they have a MySQL sample database. If you click on this, it will take you to the link where you can download the database. So they have this download link which says download MySQL sample database, and the name of the database is classic models. Alright, so we are going to use this classic models database throughout our demo session. If I expand the tables section, you can see there are a lot of tables that are present inside this classic models database. We have cricket, customers, there's employees, office, there's orders, order lines, and many more. So for our subquery, we'll be using two tables, that is order details and products table. First, let me show you the content that is present inside the products table first. If I run this, you see here it says 110 rows returned, which means there are 110 different products that are present in our table, which has the product code, the product name, product line. We have the product vendor, description, quantity in stock, buy price, MSRP. The other table we are going to use is order details, which has the details of all the orders. Let me show you the records order details tables has. Okay, so there are 1000 records present in this table. You have the order number, the product code, quantity ordered, price of each item. You have the order line number as well. Okay, now we want to know the product code, the product name, and the MSRP of the products whose price of each product is less than $100. For this scenario, we are going to use two different tables and we are going to write a subquery. Okay, so if you see here in the order details table, we have a column called price each. I want to display the product code, the product name, and the MSRP of the products which have a price of each product less than $100. So the way I'm going to do is I'll write select product code, comma, product name. Now one thing to remember, that this product name is actually present inside our products table and product code is present in both the tables, that is products and order details. Here you can see this is the product code column, comma, MSRP which is present inside the products table again, from my table that is products, where I'll write product code. I'm going to use the in operator. Next I'll write my inner query, that is select product code from my table order details, where my price of each product is less than $100. Let me run this. Okay, so you can see there are total 83 products in our table which have a price less than $100. You can see the price here. Okay, now we learn another advanced concept in SQL which is known as stored procedures. I'll just give a comment saying stored procedure. Okay, so first let's understand what is a stored procedure. A stored procedure is an SQL code that you can save so that the code can be reused over and over again. So if you want to write a query over and over again, save it as a stored procedure and then call it to execute it. So in this example, I want to create a stored procedure that will return the list of players who have scored more than 6 goals in a tournament. So I have a database called SQL_IQ. These are a few databases that I have already created. So this database has a table called players. If I expand the tables option, you see we have a table called players and you can see the columns player ID, the name of the player, the country to which the player belongs to, and the number of goals each player has scored in a particular tournament. So I'll write a stored procedure that will return the list of top players who have scored more than 6 goals in a tournament. So first of all, let me begin by using my SQL_IQ database. We'll run it. So now we are inside the SQL_IQ database. Let me select star from players to show the values that we have in the players table. You can see there are 6 players in our table. We have the player ID, the names of the players, the country to which these players belong to, and the goals they have scored. So I'll write a stored procedure. So the stored procedure syntax is something like this. It should start with a delimiter. Okay. In the delimiter, I'll write ampersand ampersand. Next, I'll write create procedure followed by the procedure name. Let's say I want to name my procedure as top_players. Next statement is begin. After begin, I'll write my select statement. I want to select the name of the player, the country, and the goals each player has scored from my table, that is players, where I'll write goals is greater than 6. I'll give a semicolon. Then I'll end my procedure with a delimiter that was double ampersand. Next, I'll write delimiter and give a semicolon. Now the semicolon suggests this is a default delimiter. And there should be a space. Okay. Now let's run our stored procedure. There you go. So you have successfully created our stored procedure. Now the way to run a stored procedure is you need to use the call method and give the procedure name, that is top underscore players in our case, with brackets and a semicolon. Let's execute it. Okay, there is some problem here. So we made a mistake while creating a procedure. The name of the column is goals and not goal. Let me create that procedure again. Okay, it says the procedure top underscore player already exists. Let's just edit the procedure name. Instead of top player, we'll write it as top players, and similarly we'll edit here as well. Now let's create it again. Okay, now to call my procedure, I'll write call space followed by the procedure name, which is top underscore players. If I run this, you can see we have 2 players in our table who have scored more than 6 goals. So we consider them as the top players in a particular tournament. Alright. Now, there are other methods that you can use while creating a stored procedure. One of the methods is by using an in parameter. So when you define an in parameter inside a stored procedure, the calling program has to pass an argument to the stored procedure. So I'll give a comment, stored procedure using in parameter. Alright. So for this example, I'll create a procedure that will fetch or display the top records of employees based on their salaries. So we have a table in our SQL underscore IQ database which is called employee details. I'm going to use this table. You can see we have the name of the employee, the age, sex, then we have the date of join, city and salary. Using this table, I'll create a procedure that will fetch or display the top records of employees based on their salaries, and we'll use the in parameter. So let me show you how to do it. I'll write delimiter. This time I'm going to use /. I'll write create procedure followed by the procedure name. Let's say SP for stored procedure, sort by salary is the name of my procedure, and inside this procedure I'll give my parameter in. I'll create a variable var and assign a data type integer. Then I'll write begin followed by my select statement, where I'll select the name, age, salary from my table name, that is EMP details or employee details. I'm going to order this by salary descending, and I want to display limited number of records, so I'm using this limit keyword and my variable var which I created here. I'll end my select statement. I'll end my stored procedure with /, and I'll go back to my default delimiter, that is semicolon. Alright, so let me run this. There should be a space here. Alright, so let's run this. Okay, you can see we have successfully created our second stored procedure, which is sp underscore sort by salary. Now you can also check whether the stored procedure was created or not. Here you have an option to see the stored procedures. Let me just refresh this, and you can see we have 3 stored procedures that we have created so far. One is sp underscore sort by salary, the other two were top underscore player and top underscore players. Okay, now let's call our stored procedure. I'll write call space followed by the stored procedure name, which is sp underscore sort by salary, and inside this I'll give my parameter, which was actually var, and this var we have used in limit. Let's say I want to display only the top 3 records of the employees who have the top 3 highest salaries. Okay, so let me run it. There you go. So Amy, Sarah and Jimmy were the top 3 employees who have the highest salary. So you saw how you could use the in parameter in a stored procedure. We created a variable, and that variable we used in our select statement, and we called our stored procedure and passed in that variable. Okay, now instead of a select statement inside a stored procedure, you can also use other statements. Let's say update. So I'll create a stored procedure to update the salary of a particular employee. So in this procedure, instead of select statement, we'll use the update command. In this example, we'll use the in operator twice. So let me show you how to do it. I'll write my delimiter first, which is going to be /, then I'll write create procedure. My name of the procedure is going to be update salary, and inside the update salary name I'll write in, and then temp underscore name, which will be a temporary name variable, and the type I'll assign is varchar20. I'll again use my in parameter. I'll write in. Next, my other variable would be new underscore salary, and the data type would be float. I'll write begin and write my update command or update statement. I'll write update table name, that is employee details, set salary equal to new underscore salary, where name is equal to my temporary variable, that is temp underscore name. So this is my update command, and I'll end the delimiter. Alright, so let's run this. Okay, we have successfully created our stored procedure. If I refresh this, you can see I have my stored procedure update underscore salary. Okay, now let's say, first of all, I'll display my records that are present inside employee underscore details table. Okay, so we have 6 rows of information. Let's say you want to update the salary of employee Jimmy, or let's say Mary, from 70,000 to, let's say, 72,000, or let's say 80,000. So I'll call my stored procedure, that is update underscore salary, and this time I'm going to pass in 2 parameters. The first parameter will be the employee name, and next, with a comma, I'll give my new salary that I want to. So my employee name, let's say, is Mary, and the salary I want to be updated is, let's say, $80,000. I'll give a semicolon and I'll run it. You can see it says one row affected. Now let's check our table once again. There you go. If you see this record, for Mary we have successfully updated the salary to $80,000. Now moving ahead, we learn to create a stored procedure using the out parameter. So I'll give a comment, stored procedure using out parameter. Okay. So suppose we want to get the count of total female employees. We will create total employees as an output parameter and the data type would be an integer. The count of the female employees is assigned to the output variable, which is total underscore EMPs, using the into keyword. Let me show you how to write a stored procedure using the out parameter. So first I'll declare my delimiter to / I'll write create procedure followed by the procedure name. It is going to be sp underscore count employees, and inside this I am going to give my out parameter and the variable name, that is total underscore EMPs, which is total employees, and the data type will be integer. Next I am going to write begin followed by my select statement, that is select. I want the count of total employees, and the output I am going to put into my new variable, that is total underscore EMPs. From my table, that is EMP underscore details, where sex is equal to F, which means female, I'll give a semicolon. Next I'll end it with the delimiter, and I'm going to change the delimiter to a default delimiter, that is colon. So let me tell you what I am doing here. I'm creating a new stored procedure, that is sp underscore count employees. Using this stored procedure, I am going to count the total number of female employees that are present in our table emp underscore details. So I've used my out parameter and I'm creating a new variable called total underscore EMPs. The data type is integer. Here in the select statement, I'm counting the names of the employees, and the result I am storing it in total underscore EMPs. I have used my where condition where the gender or the sex is female. So let's run this. Okay, so we have created our stored procedure. Let's refresh this. Okay, you can see we have our new stored procedure sp underscore count employees. Now to call it, I'll write call the name of the procedure, that is count underscore sp underscore count employees. Within brackets I'll pass in the parameter as @f underscore emp. I'll give a semicolon. Then I'll write select @f underscore emp as female employees. Okay, so as is an alias name. Let's run this one by one. First I'll call my procedure and then we'll display the total number of female employees. You can see in our table we have 3 female employees. Alright, now with this understanding, let's move on to our next topic in this tutorial on advanced SQL. Now we are going to learn about triggers in SQL. So I'll give a comment here, triggers in SQL. So first let's understand what is a trigger. So a trigger is a special type of stored procedure that runs automatically when an event occurs in the database server. Now, there are mainly 3 types of triggers in SQL. We have the data manipulation trigger, we have the data definition trigger, and login triggers. In this example, we'll learn how to use a before insert trigger. So we will create a simple students table that will have the student's roll number, the age, the name, and the student's marks. So before inserting the records to our table, we'll check if the marks are less than 0. So in case the marks are less than 0, our trigger will automatically set the marks to a random value, let's say 50. So let's go ahead and create our table, that is students. Alright. So I'll write create table student. Now this table will have the student roll number. The data type is integer. It will have the age of the students. Again, the data type is integer. We have the names of the students. So the third column would be name. The data type would be variable or varying character. Size I'm giving it as 30. Finally, we have the marks as floating type. So let's create this table, which is student. So we have created our table. Now I'll write my trigger command. So trigger command will start with delimiter, like how our usual stored procedures have. Next, this time I'll write create trigger. Then you need to give the name of the trigger, that is mark underscore, let's say verify. I'm going to use a before insert trigger, so I'll write before insert on my table name, that is student. Next I'll write for each row if new dot marks is less than 0, then we'll set new dot marks equal to 50. So this is my condition. First we'll check before inserting. If any student has marks less than 0, we'll assign a value 50 to that student, because usually the marks are not less than 0 in any exam. I'll write end if semicolon and I'll close the delimiter. So this is my trigger command. I'll run it. It says trigger already exists. So in this case we need to update the trigger name. Let's say I'll write marks underscore verify underscore student for ST. Let's run it again. Okay, there is an error here because in our table the column name is mark and not marks. So here we need to change it as mark instead of marks. Alright, let's run it. Okay, so we have created our trigger. Now let me insert a few records to the student table. So I'll write insert into student. I'll write values. I'll give the values as 501, which is the student roll number. The age is, let's say, 10. The name is, let's say, Ruth. And the marks is, let's say, 75.0. Give a comma. We'll insert our second student record. Student roll number is 502. Age is 12. The name is, let's say, Mike. And this time I'm purposely giving a value of minus 20.5. Give another comma. We'll insert the third record for student roll number 503. Age is 13. The name is Dave. And let's say the marks obtained by Dave is 90. Now we'll insert our final record for student number 504. The age is 10. Name I'll enter as Jacobs. And this time again I'm purposely giving the marks in negative 12 point, let's say 5. I close the bracket and give a semicolon, and I'll run my insert statement. Okay, so we have inserted 4 rows of information to our student table. Now let me run the select query. I'll write select star from student. If I run this, you see the difference. There you go. So originally we had inserted for 502 the marks was minus 20.5, and for 504 for Jacobs the marks was minus 12.5. Our trigger automatically converted the negative marks to 50, because when we created our trigger we had set our marks to 50 in case the marks were less than 0. So this is how a trigger works. Now you can also drop a trigger or delete a trigger. You can just write drop trigger followed by the trigger name. In this case our trigger name is marks underscore verify underscore st. I'll just paste this here, and if you run this it will automatically delete your trigger. I'll give this as a comment. Okay, now moving on. Now we are going to learn about another crucial concept in SQL which is very widely used. This is known as views. So views are actually virtual tables that do not store any data of their own but display data stored in other tables. Views are created by joining one or more tables. I'll give a comment as views in SQL. Okay. Now to learn views, I am going to use my table which is